So the planetary boundary science now has 50 years of scientific advancement, and it's based on three fundamental pieces of evidence that has been advancing over the past 30 years. And the first one is that we've entered a whole new geological epoch, the Anthropocene. Anthros, Greek for humans. We're now, as humanity, the world as we know it, the dominating force of change on planet Earth. The scale, the speed, and the connectivity has reached a point where we are starting to see the first indications of hitting the ceiling of hardwired biophysical processes that regulates the stability, the resilience, and the life support on Earth. The evidence for this comes not from models, not from theories, but from observations. It's the great acceleration curves that you see here. They are now iconic. They were published the first time, actually 3 years before the first Planetary Boundary Science paper in 2009 by the International Geosphere Biosphere Program, and continuously being updated by the Stockholm Resilience Centre and partners at Future Earth. What you see here is from 1750 until today. It's the same x-axis on all graphs. The blue curves are the socioeconomic pressure points, and the green curves are the impacts on the Earth system. You don't have to go through the details on these curves. Just look at the pattern. They have the same configuration up until the mid-1950s. We have environmental impacts, and they are linear. They're incremental. But then we have this great acceleration point, and we have an exponential rise of pressures. And we're now at the top of these curves. And you can pick essentially any environmental parameter that matters for human well-being. They look the same. If it's carbon dioxide or sulfurs or nitrates or biodiversity loss or deforestation, you have this point of acceleration and saturation in the recent decades. So that is element of evidence number one, which of course provides ample evidence that we need to redefine what we mean by sustainable development, because now we're suddenly at a point where it doesn't matter anymore to only be concerned about environmental impact at the local scale. Everything has to add up at the global level because we are a global force of change. The second part of evidence is that we today have paleoclimatic science showing clearly that the Holocene, the last 12,000 years of warm interglacial since we left the last ice age, is not only an extraordinarily stable state of the planet, and you see here a graph from a recently published State of the Climate Report 2025. You see the last 10,000 years, if you look at the graph on the right here, global mean surface temperature on planet Earth, the 0 point here is 14 degrees Celsius, is the pre-industrial average temperature on Earth. Just look at how extraordinarily limited the temperature variability is since we left the last ice age, which was a -5 degrees Celsius ice age temperature. We come into the Holocene. We are barely just a few thousand years into the Holocene, and we shift from being hunters and gatherers, a few million people living in caves, pastoralists, to domesticating animals and plants. And off we go after the Neolithic Revolution to develop sedentary societies, innovation pathways, communities, civilization as we know it. And we are today at a point where we can scientifically say with very strong evidence that the Holocene is the only equilibrium state of the planet that we can know for certain can support the world as we know it. Our world depends on the Holocene. And what you then see is one of the hockey sticks here, how we are pushing ourselves outside of the very narrow corridor of life that the Holocene provides. The latest science actually shows that the maximum variability of temperature during the Holocene is 14 degrees Celsius as the global mean surface temperature, plus minus 0.5 degrees Celsius. Can you imagine? The warmest temperature over the past 12,000 years has been 14.5. And we're now currently at a point of very soon, within the next 3 to 5 years, inevitably going to breach the 1.5 degrees Celsius limit, which means we are a factor 3 higher temperature than the maximum temperature that has enabled civilizations to develop on planet Earth since we left the last ice age. And we are following a pathway that would take us to up against 3 degrees Celsius of global mean surface temperature rise within this century, which actually would wind back the climate clock. The last time we had that kind of heat on planet Earth is even outside of the Quaternary. You have to go further back than 3 million years to find an equivalent. So this is piece of evidence number 2. We have a reference point for the planet we depend on, the planet that can provide life support and human well-being as we know it. And this is a tremendous breakthrough because it means that when we attempt to define a safe operating space for humanity within planetary boundaries, we need something to measure against, and we measure against the Holocene. The graphs you see to the left here is the unfortunate, but also really important data sets showing that the great acceleration curves unfortunately continue rising. We have not bent the curves yet. So this places even more the planetary boundary science in a sense of urgent need, because they can provide the boundary conditions or the guardrails for us to urgently bend the curves away from danger. The third and final piece of evidence is tipping points. And here you have the latest update on the spatial distribution of climate tipping elements. 6 of them, as you see, are up in the Arctic region, of course, including the Greenland ice sheet, boreal permafrost, the Labrador Sea Current, the AMOC, the Amazon rainforest. 3 of them are in Antarctica, the West Antarctic ice sheet, the one that we're most concerned with, and the low latitude coral reef systems. I show this graph just because it gives a very clear visual that these tipping point systems are distributed across the entire planet. They fulfill 2 criteria. One is that they are scientifically proven to contribute to regulate the stability of the climate system on planet Earth, which ultimately controls the living biosphere on planet Earth. And secondly, we also know that they have multiple stable states. Push them too far, push them away or beyond safe boundaries, and they risk irreversibly shifting from a state that can provide resilience and overall dampen and cool the planet under stress, but cross a threshold and they will irreversibly move towards a state that is less able to provide life support, but also generically amplify warming. So these are the 3 pieces of evidence that takes us to this heuristic equation that actually form the basis of the planetary boundary science framework, namely the Anthropocene plus the Holocene as the reference point for the planet we depend on, our Garden of Eden, plus the fact that tipping points are hardwired, they are biogeophysically integral to the Earth system. A healthy planet in a Holocene equilibrium state is dominated by dampening feedbacks because the tipping element systems are in a healthy rainforest state, a stable ice sheet state, a functioning AMOC state. But if they're pushed too far, the permafrost will thaw and emit greenhouse gases, methane and carbon dioxide. Rainforests can irreversibly become bush savannas, releasing carbon, losing biodiversity, changing hydrology. That is what we are using as the scientific reference points and measures to be able to position and quantify the safe boundaries. What are then the planetary boundaries? Well, the planetary boundaries provide us with the guidance and for humanity's journey on planet Earth in this situation of human pressures in the Anthropocene. The framework answers 2 questions. Question number 1 is, well, if we now understand that we depend on the Holocene and that we have the pressures on the planet, the question number 1 is, what are the Earth system processes that regulates the functioning, the resilience, and the stability of the planet? And once that question is answered, and we have invited scientific experts across all disciplines of Earth system research, and we've identified 9 planetary boundary systems and processes, those are the ones you see on the screen here, that we have scientific evidence of regulating the functioning and stability of the planet. Once these are identified, question 2 arises. Can we, for each one of these, identify a control variable, a data set, an indicator, which number 1 is coupled to the state of the boundary, but number 2, where we have time series, where we have global data, where we have peer-reviewed published scientific evidence of the uncertainty ranges when you enter points of risk of causing potentially tipping points, but not necessarily. It could also be the boundaries do not have evidence of tipping points, but that they have evidence of regulating the stability of tipping points in other boundary systems. For example, stable ecosystems to avoid carbon loss that could knock over the climate systems and therefore shut down the AMOC. So we're looking at boundaries to keep the system intact. What you see here is that the 9 boundaries, obviously, as one of them, includes the climate system, a stable climate system. But you also have the biosphere boundaries of biosphere integrity, which is genetic diversity and functional diversity of the living species on planet Earth, land system configuration in terms of biomes, and we use the big forest systems as being the systems that we today understand plays the most dominant role in regulating the stability of both hydrology and climate system. Of course, the bloodstream of the whole Earth system, the global hydrological cycle, which is behind all life and all biophysical functions and resilience in the Earth system. The biogeochemical fluxes of nitrogen and phosphorus, the biochemical flows, the sister cycles to the carbon cycle, the nitrogen and phosphorus cycle, stability of the ocean, where we have ocean acidification as the boundary process, aerosol loading, the understanding that air pollutants at the lower atmosphere is not only an enormous health threat, it's also regulating monsoon systems, therefore freshwater supply and climate stability. The stratospheric ozone layer, the protective stratospheric ozone layer, which protects life on Earth from dangerous UV radiation. And obviously, finally, what we call novel entities, the loading of chemical compounds created by humans into the Earth system, everything from microplastics to PFAS to nuclear waste, all forms of additions that risk undermining life on Earth. There you have the 9. We have been working on these for better parts of 15 years now, identifying control variables for all of them. So these 9 boundaries, which you see furthest to the left here, they have 13 control variables. So climate, for example, is measured both in terms of carbon dioxide concentration and climate forcing from all greenhouse gases in watts per square meter. Biosphere integrity is both in terms of species loss and in terms of human appropriation, net primary production. Just to give you examples of the fact that there's a lot of science here, and actually over the past 15 years, you have more than 1,500 peer-reviewed papers, even with planetary boundaries in the title, scrutinizing, criticizing, advancing the research, and improving many of the control variables. Independent scholars in water research have brought in green and blue boundary definitions for control variables, for example. So today we have freshwater boundary representing both soil moisture, green water, the moisture in the soil that powers the photosynthesis, and blue water, what is the minimum amount of liquid water in groundwater, lakes, and rivers to keep the functioning of large biomes intact. So it's quite an exciting journey of science that has brought us to a point where we today are actually able to quantify all the 9 boundaries. And here is one of the latest and most recent scientific assessments. This is from the 2025 Planetary Health Check. We actually update the planetary boundary science every year now. And what you see here is in green, the safe operating space. So these are the quantifications of the safe boundary levels. The yellow zone here is the uncertainty range in science. So the only normative element of the planetary boundary science is that we do, based on precaution, place the boundary at the lower end of the uncertainty range in science. So the yellow part is what I call a danger zone. You exit a safe part where you have a high likelihood of keeping the Earth system in Holocene-like interglacial conditions to support humanity. You enter the yellow zone, things can go wrong, but you're still in the uncertainty range in science. Go beyond that yellow zone, and you exit the upper end of uncertainty range as we've estimated in the scientific assessment, and you enter the high risk zone, the red zone, where things can really go wrong. not with 100% certainty, but the likelihood of irreversible changes increases significantly. The latest assessment, as what you see here, is that 7 of the 9 planetary boundaries are outside of their safe operating space. So this is a really dire diagnostic. It shows ample scientific evidence that we have a planet which is subject to multiple stressors. It's not only a climate crisis, it's a climate crisis occurring while we at the same time are undermining or degrading the resilience of the living biosphere's capacity to buffer that stress by losing biodiversity, degrading land, over-consuming fresh water, overloading reactive nitrogen phosphorus, even allowing the ocean to gradually lose its resilience and strength, both in terms of marine ecosystems and in acidification, and with a very significant and dangerous overloading of novel entities. It's only the stratospheric ozone layer, which is a success story, because in the 1980s, we were actually outside of the safe operating space. We were threatening the protective stratospheric ozone layer by emitting chlorofluorocarbons, which we were using to cool in air conditioners and refrigerators and in spray cans. Science warned humanity. 3 Nobel laureates were given a prize for the science. The Montreal Protocol was signed in 1987, and we started to veer off from danger, and it has brought us back finally within a safe operating space, and the ozone hole is gradually closing. It's a success story. It's an example that we can be stewards of the planet and that we can be stewards of planetary boundaries. But as you see, we are in a dangerous position with regards to the state of the planet today, a planet showing signs of losing resilience. And let me just share with you briefly that this is unfortunately, what you see on the screen here is unfortunately translating into observations right as we speak. Global warming is accelerating faster than we had expected. We're starting to see signs of reduced carbon uptake capacity in forest systems on planet Earth. We're seeing extreme events like droughts, floods, fires, disease patterns increasing both in frequency and amplitude. We're seeing a planet showing clear signs of stress. And that is exactly, unfortunately, what we can expect when we are, for a long time, continuing to operate outside of the safe operating space. This is where we were before we started the Great Acceleration journey. Here you have the pre-industrial world of, you could think of it as being in the early 20th century. We then already in 1950, at the kickoff point of the Great Acceleration, just at that nick of the curves, we actually already had in our assessments lost biodiversity and loaded with chemicals. Remember Rachel Carson and Silent Spring and the DDT crisis we had in many river systems across the world. So already early, we had challenges, but look, overall, we were within the safe space. And it continued in the 60s, in the 70s, with incremental changes. And it's not until the 80s and 90s where we start seeing really significant breaching of both the climate boundary, which is breached in 1990, essentially, or late 1980s. We had the first testimony by Professor Jim Hansen, one of the co-authors of the first planetary boundary science, in US Congress in 1988, warning for the dire risks of continuing breaching the climate planetary boundary. Look at nitrogen phosphorus, which was already massively overloading through the Haber-Bosch process of fertilizer production in unsustainable mechanized agricultural systems. And it just continues in the 2010, we are still within 6 of the 9 boundaries transgressed. And it's not until in the latest 2024 planetary health check that we are unfortunately forced to conclude that we're now also breaching the ocean acidification boundary, taking us to 7 boundaries transgressed. And here you have again the 2025 latest update. So this is a guide for us to be able to avoid unmanageable outcomes of our journey into the future. And we have now recognized that we can no longer have the 7-year cycle of the science, which is what it has taken historically to update all this research. Now we update the science every year. We're bringing in Earth observation data, a broader community of Earth system modelers, tipping point scientists. We even started a tipping point model into comparison to be able to bring Mother Earth to the doctor each year for health controls rather than doing it in a 7-year cycle. This means we're actually using a blood sample test equivalent to make the analogy. Here is a planet with its biogeophysical organs under stress. And as a blood sample test, you have the safe operating space, the danger zone, and the high risk zone. And it confirms the 7 planetary boundaries across all the control variables, which are the equivalent of the blood pressure systems and the different parameters that you want to measure regularly to be able to not only have the right diagnostic, but also to find a cure. And the purpose of all this is to be able to have a guide for investments into bringing us to a cure. And the reason why I believe that this is not only so important, but also of urgency is shown in this summary graph, which we presented for the first time in the Planetary Health Check. So now we have statistically integrated all the 9 boundaries into one measure, which is admittedly statistic and based on expert elicitation of where is the planet if you try to make one health statement. Now, as you see, we place the planet, not surprisingly, outside of the safe operating space. So we are in danger. We have a planetary crisis on our watch. But the conclusion is also that we're not yet deep into the red zone. We're still in the high danger zone, moving closer and closer to the high risk zone. But the window is still open. That's the scientific assessment today. The window is still open to turn this around to be able to bring us back towards a safe landing. In summary, when you look at the functioning of the Earth system, despite all the stress, despite all the indications of losing resilience, the biogeophysical systems, both on land and on ice and in the ocean, remain dominated by dampening feedbacks. The ocean is still absorbing 90% of heat. It's still absorbing 25% of carbon dioxide. The ecosystems on land are still operating and doing all they can biogeophysically to keep the hydrological cycle, the carbon fluxes, the energy and material flows reasonably under control. So this means that the window is still open, even though it's rapidly closing. It gives the dashboard for development of the world, our world, to navigate the Anthropocene. And what we now are doing is we're connecting this diagnostic for patient Earth to the cure. And the cure, excitingly, cuts across all sectors of the planetary boundaries, from a food system transformation to an energy transition to circular material flows to all forms of planning and system changes, how we design our built environment and how we operate our fashion industry. And interestingly, when you start mapping the solutions here, they exist and they can generally be scaled and they can even compete with the planet damaging practices that we're operating today. So the vision here is to combine the science of the planetary boundaries, where each boundary translates to a finite budget within which the economy needs to not only operate, but also where industries need to innovate. And we know that constraints are the mother of innovation. And we see more and more evidence also of exponential positive curves on renewable energy, on efficiency, on possibilities of regenerative agriculture that can take us significantly towards not only a safe landing, but also a pathway that can give better outcomes both for prosperity and for equity. So this is not a journey only of warnings. It's also a tool to accelerate the pathway towards a safe and just landing for humanity on Earth.